The scope of this video is to explain the electrical operation of the mechanical timer top-load washer. Due to variations in the model line, this video is not model specific. Refer to the safety information, wiring diagram, and the service manual for information on your particular washer. This machine must be installed, adjusted, and serviced by qualified electrical maintenance personnel, knowledgeable of this type of machinery. They must also be aware of the potential hazards involved. Failure to observe this warning may result in personal injury or even death and may void the product warranty. To diagnose an electrical problem, we must have a full understanding of the operation of a top-load washer. Important to our knowledge is the customer operation. Timer chart, wiring diagram, and electrical components. Let's go through the timer chart and look at some of the electrical components before we start our electrical tests. The timer chart is a table that shows the sequence of cycle operation and the circuits made by contacts that close during each increment. The timer chart sequence indicates the washer will wash, spin, rinse, followed by the final spin. During wash, several circuits are made. Next to the circuit table are a pair of lettered contacts. These contacts are closed during increments in the timer indicated by a darkened line. As an example, in wash, the fill contacts L, S, and P are closed in increments 1 through 8 as indicated by the yellow line. Now let's look at the wiring schematic and connection drawings. The wiring schematic gives us a clearer illustration of the current flow in the electrical circuit of the washer. The connection diagram is the physical diagram of wires, connectors, and electrical components. We'll use this diagram as a location aid. We must be able to recognize the electrical switches and loads in the circuit. Let's identify them. The switches consist of the pressure switch, timer contacts, lid switch, temp selector switch, and fabric selector switch. The motor, mixing valve, and timer motor are the loads. Now we're ready to begin. After loading the washer and making cycle selections, the operator actuates the coin slide, which advances the timer from the off increment into wash. Let's follow the wiring schematic from wash fill to wash agitate. For reasons of clarity, we will show L1 represented in red and neutral shown in blue. Line 1 and neutral potential are present elsewhere in the schematic, but we will concentrate on the circuits that are being discussed. Let's start the cycle and follow the current flow. When the loading door is closed, the lid switch provides voltage to the timer at contact LS. The timer is advanced from off into wash by the coin slide. LS to P, PP to K, TM to M, V to W, F to K, and G to L are now closed contacts in the timer. LS to P provides voltage to the pressure switch common terminal number 1. Normally closed contact terminal number 2 on the pressure switch provides voltage to the wash temperature selector switch. Depending on the position of the switch, voltage is sent to the mixing valve. Neutral is routed through the thermal protector of the motor, then to the timer motor and mixing valve. This will disable fill and timer motor circuits if the motor thermal overload opens. At this point, the washer is filling, but the timer motor and motor agitate circuits are not complete. When the water reaches a full level, the pressure switch becomes satisfied and switches from normally closed terminal number 2 to normally open terminal number 3. The fill circuit is opened and the voltage is now present at terminal TM on the timer. With voltage to the timer motor, the timer will now begin to advance. Let's follow the current flow to the motor run and start circuits in agitation. Line 1 is routed through TM to M to L2 on the fabric selector switch. Set on the normal selection L2 to C provides the path to the high winding. The neutral side of the high winding is made through the thermal protector. Line 1 is also routed through K to F and the start capacitor to the start winding. The neutral side of the start winding is made from the thermal protector through L to G in the timer. With voltage across both windings, the motor will start and run. A centrifugal switch in the motor opens the start winding circuit once motor RPM is achieved. We'll see how the fill and agitate circuits in wash are made. Now let's troubleshoot a fill or motor agitate problem using a digital multimeter. Only qualified personnel knowledgeable of electrical test procedures, test equipment, and appropriate and necessary safety precautions should attempt adjustments in troubleshooting. Always disconnect power from the machine before attempting any service procedures. Before making any electrical checks, let's test the incoming line voltage at the outlet. Neutral is the large terminal. Line 1 is the small terminal. Ground is the rounded terminal. The polarity check is made to ground. Line 1 should read voltage to ground, indicating proper polarity. Under load, the line voltage should be 120 plus or minus 12 volts AC. For test purposes, we will read voltage to neutral. Remember that neutral is routed through the thermal protector to the motor before it reaches the mixing valve, timer motor, and motor windings. To troubleshoot the fill circuit, start by locating an easily accessible spot in the middle of this series circuit. The pressure switch is easy to get at and will indicate which direction we need to test. Attach the negative lead of the voltmeter to neutral of the incoming power cord. Advance the timer into wash using the coin slide. Check for line 1 voltage at the common terminal number 1 on the pressure switch. Check for line 1 voltage at the NC terminal number 2. Line 1 is present at both terminals, indicating that the switch is closed and our problem is further on in the circuit. Check for line 1 voltage at L2 on the temperature selector. With the switch set on cold, check for line 1 voltage at terminal C. Now that we are at the load in the circuit, we will test across the coil with a voltmeter. There is voltage when checking across the coil. The windings in the coil could be open. The valve could be mechanically inoperative, or it could be simple as no water pressure available to the valve. Let's test the motor agitate circuit. We have shown the circuitry that is made to power the motor windings. We'll check for voltage across these windings at the motor plug. Set the fabric selector switch to normal. A blue wire at plug pin number 7 provides line 1 voltage to the high-speed main winding. To prove that the thermal protector is good, we will test for neutral at the white-red wire pin number 8. Note that a yellow wire is used on earlier models. In agitate, a red wire pin number 1 provides line 1 voltage to the start winding. A brown wire pin number 6 provides neutral to the start wind. With voltage across both windings, the motor should start and run. The centrifugal switch opens and removes the start winding circuit once motor RPM is achieved. In spin LS to TM, bypass the pressure switch. The motor rotation is reversed by reversing the polarity of the start winding. This is accomplished through the timer contacts K to G and L to F. Line 1 enters the motor on the brown wire and neutral on the red wire. Because the motor uses the same circuitry to run in agitation, it should run in spin. We hope this video has helped to expand your knowledge of the electrical operation of a top-load washer. Understanding wiring diagrams, machine operation, and the proper use of a digital multimeter will make you a better diagnostic technician.